Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you can follow me on Twitter as well. In this particular video, we are going to look into informers and caching and some of the other things that are very important or very basic building blocks of writing Kubernetes controllers. So let's just go ahead and try to have a very brief look into what exactly a controller is, and then we can discuss about how informers help us to write a Kubernetes custom controller. So we have already discussed about Kubernetes custom controllers in detail in one of the previous videos. So maybe I'll link that down and you can uh, watch that. But if we talk about Kubernetes custom controllers, so they are just an application, let's say, that is going to listen on a particular Kubernetes resource, for example, let's say pod, and as soon as a specific pod is created, this particular application that is deployed and listening on pod resources is going to do certain things, and that thing can be anything. For example, let's say if you want to write a custom controller that listens on a pod resource, and as soon as a pod resource is created, this controller creates a respective service to expose that particular pod resource. So this application that we have deployed here, this application can do anything, but this responds on the resources that are being created on Kubernetes cluster, and this is the basic definition of Kubernetes custom controllers. Now if we talk about how this application is going to know if a particular resource has been created, deleted, or updated, so we should have a mechanism to let this particular application know if an application has been created, it has been, let's say, deleted or updated. And and once this application gets to know that this particular application or this particular pod was created, it can do the things that it is supposed to do for the creation of the pod, and things like that. Now if we talk about how this application gets to know about these events, let's just go back and look into this is the program that we wrote in one of the previous videos. So I'm just going to write a line of code here just to show you how. Yeah, so if you remember, when we talked about all the methods that this pod interface exposes, we also looked into watch, and this particular method gives us an interface that has a channel, and this channel gets all those create, update, and delete events. So we can very well use this watch method of pod interface to get to know if a particular resource was created, deleted, or updated. So that is one way, but we don't ever use, I would say, watch method to do this particular thing or in these scenarios. And now we are going to look into why don't we do that. So let's say if we are using watch verb is going to query API server a lot of times, I would say, again and again, to get to know if a particular resource was created, deleted, or updated, and that is going to increase load on the API server, and your application, your processes are going to get slow because of those many number of requests to the API server. Because that is what watch verb does. It gets us the event for all these operations if they are done on a particular resource. In this particular example, we are talking about pod. So to resolve this particular issue, we use informers. And what informer does is, informer obviously uses watch internally, but it very efficiently leverages in memory store. And because of that, we don't necessarily have to query API server again and again to figure out all those things. So let's just go ahead and try to look into this diagram, another diagram. So if we talk about informers, let's say this is the informer that we are talking about. So what this informer does is, if we create an informer, this informer is going to call API server, and the verb that it is going to call it with is list. And once the list verb is successful, it is going to get all the details in memory, and it is going to store all those details in a store, in memory store. Let's call it store. Okay, and now we are not going to call list, now we are going to call watch. And when we call watch, we are going to update this in memory store. So by using this particular mechanism, as you can see, if we want to get something from the API server, we are not going to call API server directly, but we are going to call this store to get or list something. I hope that this makes sense. And for example, let's say once we have this store initialized, we can obviously get list the resources that we are looking for. And this is pretty easier because this informer exposes similar kind of APIs. Let's call it lister, and this lister is used to get and list the resources that have been initialized in the resource. So and the benefit of this particular mechanism is, for example, let's say if we are using watch verb to look for the creation, updation or deletion events, in that case, if there is a network issue, we will have to manually handle that. But in case of informer does that error handling and everything automatically. And as we see here, we are not going to make a call to API server every time, because informer has already initialized store. And so yeah, this is what an informer is. This is what it looks like, and it is I would say very important component of writing a Kubernetes controller, because as I said, we cannot use watch verb to look for resources. We use informers instead of watch verb. So yeah, I hope this makes sense. Now if we talk about this particular informer, we can create informer for every group version resource, every group version and resource. But that is again going to for every group version resource, if we, let's say, if we want to watch 3 group version resources, in that case, if we are creating informer for all those 3 group version resources, we are eventually going to create 3 informers, and all these 3 informers are going to talk to API server. This is again going to increase the load on the API server. So that is the reason we use SharedInformerFactory to initialize or to create informers. So I hope this makes sense. What informer is, why do we use informer, and why do we cache the resources in the in-memory store that informer maintains. So now let's just go ahead and try to have a look into this very basic code that I have written here. So this is, you should be familiar about this particular code. We are just creating client set using the config. And once we have the client set, as you can see here, we are using informers package from client go library, and we are calling new shared informer factory. Now, as I said, I think you should be clear about why do we need informer factory in case of or instead of informers. Because let's say if our application, our binary wants to watch n number of group version resources, if we are just using informers, in that case we will have to create n number of informers, and those n number of informers are going to query API server, and they eventually are going to increase load. And that is the reason we use shared informer factory instead of informers. And if you see here, this gets us shared informer factory. So now, I mean, as we can see, by calling new shared informer factory, we got informer factory, and then we can have specific informers for the resources using this particular syntax. Now, once we have the informer, we will have to start the informer. And this start, we are going to discuss about this particular thing in a bit, but if we talk about SharedInformerFactory.start, this is where this particular store or in-memory cache is going to be initialized. So we will have to run SharedInformerFactory.start. And if we talk about WaitForCacheSync, so as I said, once informer starts, informer will have to initialize the in-store cache or in-memory store that it is maintaining. So it makes a list call to the API server, and once list call returns, this particular cache gets initialized. So that is what we are trying to do here by calling WaitForCacheSync. It simply means that we are waiting for first list call to be completed, and that eventually is going to initialize the in-memory cache that informer maintains. And obviously, as we discussed, once first list call is completed, subsequent call to API server is going to be watch instead of list. Yeah. And if we talk about this particular syntax, as we discussed here, once this particular cache is initialized, this informer that we have here provides a lister using which we can get and list objects from in-memory cache. So if you see here, we are talking about pod informer that we have created, and from pod informer we call lister to get the pod lister, and we get this particular, let's say, pod from default namespace. This call, what I'm trying to emphasize is, this call is not going to API server. This call is going to get entertained, or this call is going to get responded from in-memory cache. And that is very, I would say, important thing, very useful thing if we use informers to create Kubernetes custom controllers. Now that we know what start is, what exactly wait for cache sync is, let's go ahead and try to discuss about this second argument to new shared informer factory. We know that first one is the client set that we have created. If we talk about this particular argument, so as we discussed, after first list call is successful, informer is going to try to keep store updated with current resources that are there in the cluster. And to do that, informer is going to make watch request to the API server. Now, there are chances that this particular watch request that Informer is making to API server is going to fail sometimes uh, because of n number of reasons. One of those reasons is, let's say network connectivity issues, and if this particular watch request to API server fails, in that particular case, Informer is going to make another request, another watch request to the Kubernetes API server. But because of certain reasons, let's say that resource that Informer was looking for is no more available on the cluster. So for example, let's say Informer was looking for a resource named N1 using watch verb, and this call to N1 failed, and Informer figures that out, and Informer makes another watch request to the API server. But now N1 is not N1 is not there on the cluster because of certain reasons. For example, let's say etcd, the data store that we use, has parsed this particular entry. In that case, what happens is uh, Informer is going to resync this store that we have here with the Kubernetes cluster state that we have. So this is the mechanism of resync. And one reason is that we one reason of resync is the reason that we just looked into, but that time can also be configured, and that is what we are trying to do by this particular second argument. The typical value of this argument is, I think, 10 or 20 minutes. I have just kept it 30 seconds, but yeah, typical value is 10 or 20 minutes. So after 10 or 20 minutes, Informer is going to sync the in-memory cache with the Kubernetes cluster state. I hope that makes sense. Again, if something is confusing, just let me know in the comments maybe, and I would be happy to answer them. If we go ahead and talk about, let's say, if we have configured if we have configured the default resync to be 10 minutes. So after 10 minutes, this particular cache is going to be resynced with the Kubernetes cluster state. So it simply means that resources are going to be added again on this store, and in that case, the functions that we have registered. We have not talked about these functions that we register. So before moving to that, let's talk about these functions. So another very important thing that informers provide us is we can register some functions to listen a specific kind of events. For example, if we talk about here pod informer, if a pod gets added, this particular add function is going to be called. If a pod is updated, this update function is going to be called, and if a pod is deleted, this delete function is going to be called. So informer helps us with registering these functions as well. And for example, I think it should be clear now, if we want to do something, if a pod is added, what we can do is in add func, as we see here, we can write our business logic here, or we can do some other things that we are going to look into. So now that we know how we can register functions using informers, let's just go ahead and talk about the scenario where let's assume, as I said, either this particular time that we have specified here, default resync, passes, the in-memory cache is going to be updated, and these functions are going to be called again, right? So if this function is going to be called because of resync, not because it was actually added. So if I try to explain it once more. So obviously once we have registered the functions, as soon as something is added on your Kubernetes cluster, these registered functions are going to be called obviously without any issues. But there is another case where these functions are going to be called when this particular default resync time passes. And as soon as default resync time passes, the update function is going to be called again, and we would think that the resource was updated once again, but it was not actually updated. The in-memory cache was resynced. And to actually figure out if the resource was updated or in-memory cache was resynced, what we can do is we can check the resource version of the resource that we get in update func. So in update func we get the new object, and we can check resource version of the new object to figure out if the resource was actually edited or not. If we talk about resource version, so let me just show you how what do I mean when I say a resource version. So let's edit any pod from cube system namespace, and let's edit cube scheduler, and we should be able to see resource version here as you see here. And it simply specifies in very naive terms, we can say that it simply specifies how many times a particular resource was edited, and it gets obviously stored or persisted into the data store that we use. So if we, let's say, add another label, edited :true, and last resource version was 580. Now if I save it, what I expect is this resource version should be changed. I hope this should work. And as you can see here, this pod was edited. If we get all the pods from cube system once again, cube scheduler is running again. And if I go ahead and look into the pod from cube system once again, the resource version, I find edit to be more useful. So here we go. The resource version has been changed now. The last resource version was 580, but the resource version now has been changed to 4402. And this is how we can figure out if a resource was actually edited, or we got this event because of cache resync. I hope that makes sense. The other thing that I wanted to talk about is, for example, if we look into this particular diagram, as we said, all the resources from Kubernetes cluster, not all the resources, but the resources that we have specified in the informer are going to be cached in this particular store, and we can get that particular resource using the lister interface that we see here. Now the another thing is, this is how we can use the lister of the informer. So the resource that we get here, another thing that is suggested and very important is, because all these resources are from in-memory cache, and that cache is being maintained by informer, we should not change these resources directly. We should, if we want to, we should create a deep copy of that particular resource before making any change to the resource, because as I said, these resources are being maintained by Informer, and if we change that resource, that can result in some issues of caching. If we are getting a resource directly from Kubernetes API server, by talking to Kubernetes API server, we can try to edit that. We are totally free to do that. But if we are getting a resource using listed interface, or in other words from in-memory cache, in that case we should not edit that. We should always create a deep copy of that resource, and then we edit the copied version. uh, yeah, the other thing that I wanted to talk about is, uh, if we talk about this particular method, that is new shared informer factory, there is this another function. I would say this is a function, if I'm not mistaken about functions and methods. So there is this another function, new filtered shared informer factory. New shared informer factory is going to get us informer factory for all the resources in all the namespaces. But if you think this is going to be more than needed, what you can do is you can use another function, that is new filtered shared informer factory. And new filtered shared informer factory takes a namespace and tweak list options function. So this is a function, and we can pass this function to have updated list options that is going to be applied to the resources that is going to be part of this shared informer factory. So if you want to know how we can use that, so this is how we can use that: informers dot new filtered shared informer factory. It obviously takes uh, Kubernetes client set and default racing time, let's say 10 into time dot minute, and namespace, let's say I want this shared informer factory to to get the resources from, let's say, only test namespace, because I know that my controller is going to look for the resources in this specific namespace only. And the other option is a function, tweak list options func, that has this particular signature, I would say. Now we will have to specify what v1 is. So okay, now I think you should be able to clear about the differences here. When we said new shared informer factory, this is going to get us all the resources from all the namespaces. But if this is going to be superfluous, more than needed, what we can do is we can use new filtered shared informer factory. We can specify namespace, as well as we can specify list options as well. So this is the list option, and for example, let's say we can specify list options dot label selector and things like that. So now this informer factory that is going to be created is going to only list the resources from test namespace that have this particular label selector. And similarly, we can specify another things as well. For example, we can specify API version and all these things, for example type meta and things like that. So if we want to look into list options, these are all the things that we can specify. This is from meta v1, if I'm not mistaken. Yeah. Yeah. The other thing that I wanted to talk about is using informers as we discussed. We can obviously register some of the functions. For example, let's say this is informer that we have created, and we have registered some function add func, let's say delete func, and update func. Now, the thing is, for example, let's say we have a logic written for add func, and this particular logic does a lot of things. This business logic does a lot of things, for example, creating n number of resources, and things like that. But what if that that logic failed somehow, again because of any n number of issues? So in that case, what are we going to do? Are we going to retry for the same resource? For example, let's say if we create a pod resource, I'm supposed to do n number of things. So because of Informer, the function that we have registered for add func is going to be called, and let's say the n things that I'm supposed to do, some of those things failed. So what are we going to do in that particular case? Because in that case, this particular pod that we have created p1 is it simply means that the business logic for p1 was not completed. So to facilitate or to make these things easier, what we do is, we don't necessarily run the business logic again. What we do is, we use a data structure, a queue, I would say a queue data structure, and we just enqueue the items in this particular queue. So as soon as add func is called, we are going to add that item, let's say p1, in the work queue or queue, and we would have another process running. Let's say this is the process, or function, a routine that actually has business logic, and this business logic is going to get the element from work queue, and then it is actually going to process the things. Now if we talk about the same problem, if this particular business logic failed, what we can do is, we can enqueue the element again in the same queue, because the process was not completed. But if the process or business logic was completed, in that case, what we can do is, we can run a function on the queue. Let's say this particular queue exposes a function, let's assume done. So what we can say is, once this business logic is completed for p1, what we can say is q dot done and p. So it simply means business logic for p element is done, and this is how the I would say complete workflow looks like. So this is where these queue come into picture. There are some concrete implementations of queues. For example, some of the queues provide rate limiting and things like that. So we are going to look into those things when we actually implement a Kubernetes custom controller. So I think that was pretty much it, what I wanted to talk about informers and caching. If you have any question, don't hesitate to ask them in the comments section. I would be happy to answer them. If you think this is going to be useful for your colleagues, your classmates, maybe you should share the video with them. Follow me on Twitter, and I'll see you in the next one. Thank you for watching.